You, being an artist, distribute your music across platforms, and I've always wondered, is there anything you can actually do to maximize your chances of getting more plays and more listeners? Is there anything that is statistically significant that you can do as an artist to be more successful? But first we need to connect to the API. We're using LastFM because to my knowledge that's the one that has the play rates and listener counts. In this very episode we're getting the data we need for the analysis. So we're going to be using a database, I think it's going to be LastFM, and we're connecting to its API to get a data set we need. First what we do is we sign up. If you don't have an account, create one. It's easy as can be. Here is the interface explained, all of the functions, request lines. You can apply for the API key here. Submit and it returns you the API key. So once you've got the key, you have these. I'm blurring these for a reason because that's a secret key. You don't share these, that's why I'm blurring these. So I'm resaving them to a variable and I stole the instructions from right here. So you can visit this one and see what there is to steal. Right, so what is an API? An API is application programming interface. You might have heard about user interface. So application programming interface is kind of the same but less user-friendly because it's not for users, it's for programming. So it's a special language that programs communicate in. It's a list of commands that lets our code send queries to a different piece of code and get some responses. We're gonna study some manuals to see what the actual language is and what commands we're gonna send. Every single app you use on your phone that communicates with a different app or with a database uses some sort of a programming interface. And as a user, you never see the interface. But the people who have developed the app, they do know the interface and they use it for your app to work. So we need the requests module. We assign dictionaries with requests and the user agent is myself. Here it is. And the methods are listed right here. We go chart. To get every artist possible, we just get the list of top artists sorted top down. We'll get all the artists available. We're using chart get top artists. It returns something like this: the name, play count, listeners for the artist, and some technical information. And we're gonna record the requests in a variable. By the way, I'm Vadusha and I'm the greatest expert in music, data science, and programming in the entire world, and maybe even on YouTube. Let's shorten this thing with a function so that we can just apply the function and get the data we need. Let's check how it works. So we get the top artists with this function, check the response code. If it's 400, it's an error. If it's 200, everything's okay. And let's put this all together in a table, in a data frame. There it is. The name, play count, the listeners, the ID, the URL, and some image we don't need. Right, so what is LastFM? LastFM is a platform, is a website actually. It used to be an audio scrobbler, which means it pulled information from all the music you could possibly listen on your computer, assemble it in a database, and then use the database to provide you some recommendations on what to listen next, which is a feature that every single platform has today, but LastFM seems to have pioneered. First I wanted to use like Spotify or something, but I failed to find the data I need, like play rates and listen accounts. So I did some Googling and found that LastFM had the numbers, so that's the one we're gonna be using. Though it's a bit outdated as a musical listening platform today, it's still kind of useful in terms of statistics. So if we wanna plot something, we might need a plotting library. So let's scatter plot the play count against the listeners. Nothing fancy here. Who's that? Taylor Swift is somewhat an outlier. All right, we'll do this with much more data later on. All right, let's cache the whole thing, because if we don't, we'll have to re-request every time we open the notebook. It'll take a while. The first time it took me a couple of days actually. Now that it's cached, it's about 10 minutes. We're going to be writing responses in a list. We're going to be requesting to an insane amount of pages, but it'll get fixed the second round. So while our current page is below the total pages, request this. Get top artists at a certain limit per page. So we'll iterate through pages until we reach the final page available. Let's track what page we're on, clear the output, output, and if our response has not been cached, we'll sleep for 150 milliseconds, all right, and increment the page number. As far as the programming thing goes, I'm going to be using Python as the programming language because it's the only one I know actually, and because it's well suited for data science. Once we've downloaded that, there's a list of every artist imaginable. I don't think we need the image column, so let's drop it. Let's look up tags for the artist. So lookup tags is an artist method. So we'll get the top tags for the artist, see what the artist is all about. Same thing, we're looking up tags, writing responses, joining everything, and getting a column with tags. So it took us 35 seconds to get this because it had been cached. Boom! We got the table, there's the tags, in case we need them later on in the analysis. The fun thing we're gonna do is we're gonna pull all the songs for the artists. We'll look up songs, use the get top tracks method. There's the manual for the method. In order for it to work, we need to tell what artist we need the songs from. We're defining a function where we're feeding the artist in the function and then getting back the list of songs. It took us 36 seconds because of the cache. We got the song list, song name, play count, listeners, artist, some weird attribute, and the database ID column. We have almost 500,000 tracks. That's a lot. So let's change the table a bit, add track underscore to know that this is the track related table, because we got the artist table as well, and it should say artist here for the artist. Let's convert data types so that they're not text. Integers here, rename artist columns as well, change data types in the table as well. The fun thing starts right there. We're gonna look up what there is about the tracks, these play counts or artist play counts. We need track information. We might want to investigate if track duration is any way related to track success, or if track listeners could be predicted with some other metrics, so that we could maximize some of the parameters while composing our tracks, while putting them out on different music platforms to maximize our chances of success. Right, so there's the function to look up song information. You can find the code book through the link in the description. I got the Google Colab available for you with the free code. Go check this out. Before we start going through every single track, extracting the information for the track, and it's gonna take a while because we have 500,000 tracks. Maybe not all of them have their MBID, but at least some of them do. That's still a lot of tracks. So first we need to drop duplicates to save us some effort and filter the data set to have just the ones with the ID, and it's 150,000. Still a lot of tracks. 150,000 tracks. Right, what we see here is exactly what we needed. ID, track name, and the entire information for the track listed in a dictionary here. We'll extract the information from the dictionary into separate columns later on. So what is data science? Data science is data science, the science of data. It's a set of methods that allows you to investigate data, some information, and extract useful stuff out of there. So we're going to be processing a bunch of numbers to come to conclusions. And the goal here is to find something useful, to summarize the information so that we can actually use the summaries for our benefit. Data science uses a lot of statistical tools as well as programming tools. We're going to be using a lot of data visualization, some statistical tests. And if you are as much of a stats fan as I am, you're gonna enjoy it. Okay, so full scale. This took me 8 minutes and that had been cached. So it'll take you like a couple of days if you're doing this the first time, because it's a lot of tracks and it's an individual request for each of the tracks. If you have a method to do the same thing, to pull the entire table from the API without re-requesting information for an individual track, let me know, please. I'm pretty sure there is a way to do this with SQL or something. But this, it took me a while. It sends a bunch of requests. We got this timeout in the function to sleep for 0.2 seconds, because if you don't have the timeout, about 1/5 of a second, the API thinks we're attacking the site with our requests. We're trying to pull it down, so it freezes our account. We want to avoid our account being suspended, so we have the timeout here. This timeout helps us iterate through 1,500,000 requests without looking suspicious. This whole chunk of code is freely available in a Google Colab notebook. I got the link in the description below. Go access it, copy it, and feel free to change the code, to check the code, to see if you can come to some conclusions there. Okay, we got the table. What we have, let's take a track and see what information we have. So we got the track name, ID, URL, duration, duration in milliseconds, so that's 251 seconds. The amount of listeners for the track, the play count for the track, artist information, album information, tags, sexy, alright, that's some tags there. I think we'll use the tags to define the genres of the tracks. And some additional information, summary, content, I'm not sure if this will help, but this is kind of cool. The exact time of publication. There's some temporal characteristics that we can analyze as well. So what conclusions we might come to using this info? We got the key metrics there. How many times the song is played, and that's the key success metric for the song to my mind, and how many listeners the song has. And we'll see if any of these factors contribute to these, namely the duration of the song, publication time, day of week, month, day in month, even daytime. Was it published at night or in the morning? Or maybe a specific hour is beneficial for play count. I'm not sure, but we'll test that along the way. So that's the information we need: duration, listeners, play count, top tags, and the wiki dictionary. We're pulling that, putting it in a table. So boom, there it is. There's the entire data set. Let's save that to a CSV file in case we need that, and use the semicolon as a separator because there's a bunch of commas there. We can't use comma separation. We don't need the track info column anymore. We got the information from there, so delete it. We got to convert some of the numeric columns like listeners and play count and duration to numbers. Let's extract tags. There you go. There's the lists of tags. Let's pull the publication date. We got the publication date. There's not too many tracks that we have the date for. Oh, by the way, the world today is changing rapidly. There's a lot of technology surrounding us. One thing you could do is study data science. And where to study data science? I got no idea. Wherever you like, because nobody paid me for this promotion. Just go and find some information on data science. It's fun, I promise you. Okay, let's merge the two databases. We got the artist database with artist play counts, artist listeners. And we got the track database with track play counts, track listeners, and all the other track information. We're going to merge these so that we have an entire table containing artist name, artist play count, artist listeners, track name, track play count, track listeners in a single line so that we can compare the things against each other. So we merge the two data frames on the ID number because it's long and unique. We can use it as a merge identifier. Okay, so we still have nearly 500,000. Let's drop the missing values. We dropped around 50 lines there. Oh, and I'd really appreciate you liking this video and subscribing to the channel because it lets YouTube know the video is interesting and lets it show it to more people. That's my kind of goal here. This is gonna help me a whole lot. Please do if you don't mind. All right, now we need to extract genre information from tags, which is somewhat complicated. Let's see what tags there is. So we're pulling all the tracks, getting the unique values from the list. Oh, it's 33,500 tags. That's a lot of tags. We're not gonna browse manually through all of them. We need a more automated way to do this. Let's lowercase the tags and drop duplicates and see how long that is. Still same number of rows. That's depressing. Let's remove the artist name from the list. Then no spaces artists with spaces deleted and artists with underscores because we don't know how they put them in. Still 30,000. That's too much. Right, we do need another way of doing that. So how about we get the top tags from the entire database, then see what tags there are and sort them into genre-related tags and other tags. And then scroll through genre-related tags and assign a genre to each tag. We need a short list of genres for that. Some Googling required there. Let's pull the tags. There you go. Rock, electronic, scene live, alternative. I mean, that does look like genres. Let's sort them. So there's epochs and years and stuff. Then there's Canadian is not a genre. We gotta clean that up. So what I'm gonna do, I'm gonna spend some time and go through every single of those 500 top LastFM tags and pick the ones that are not genre related, as I think. So these are the ones that are not genre specific. It took me about an hour to sort through every one of them. World music, Scottish, masterpiece, relax, nice, New York, piano. So these are not genres: Irish, happy, glitch. You get the idea. So I cleared the tag lists of these tags that contain no genre-specific information and left only those tags that are genre-specific, like rock or electronic or jazz fusion or symphonic black metal. You get the idea. What we need now is to classify these tags into a smaller, limited number of groups that are genre names, like metal or rock or pop or something. What I did is I googled what genres people classify music into, and Wikipedia and some other sources gave me this. So there's the blues meta genre, there's the classical music, there's country music, there's hip-hop, jazz, metal, pop, reggae, rock, electronic, funk, punk, soul, folk, religious, progressive, extreme, indie, and other. Okay, this might sound complicated, and it is, but I manually pulled everything that sounds like blues to me and put them in a list matching the key of blues. We'll assign the blues genre to any track that has any of these tags. If it has the blues tag, it's blues. If it has blues rock, it's blues. Rock and roll, still blues. Motown, still blues, okay? Surf, blues as well. That's the way I'm doing it. Classical, same thing here. If it has opera, it's classical. If it has the choral tag, it's still classical. That's my approach to doing it. Hip-hop tags, jazz tags. Metal was impressive. There's a bunch of metal. And some songs fall into different categories. Like if it has blues rock in it, it's blues and rock. If any of the tags in a list is found in the track tag list, then it's classified as this genre. That's the simplest way I could think of. If you have a different way or you know a neural network that could do this, let me know please down below in the comments. That's my way of doing it, manually sorting through genres, which was fun actually. Indie-tronica. Did you know about indie-tronica or uplifting trance? What fun stuff is extreme music. And it's not just extreme metal genres, it's 8-bit as well. And grime is also extreme to my mind. Non-mainstream subgenres for metal, mostly metal, but there's like electronic subgenres as well and hip-hop that are extreme. My guess is extreme genres is not as prone to getting more listeners and plays as more popular and mainstream genres. We need the information to see if composing tracks in any genre is maximizing your chances of success. That is, maximizing your play rates for a track. Right, so let's write the function to go through the dataset and extract the genres. So if any of the items in any of the dictionary entries match, then it assigns the dictionary key to the track. And a track can have multiple genres, as you've already understood. We'll create separate columns with ones and zeros for genres. So if this track is rock, it'll have a 1 in the rock column. If it's pop rock, it'll have a 1 in pop and a 1 in the rock column, and zeros in the rest of the columns. For every key in our genres dictionary, so for every major genre, like extreme, progressive, religious, pop, folk, punk, you got the idea. We apply the function. If by now you're yawning, you're normal. And what we get is this kind of table. You see the genres list and a mark if the song belongs to a specific genre. This one doesn't, but there are songs that do. One more thing I want to check if mixing genres is a factor contributing to play count listeners. So if it's not just a clear-cut rock song, but instead like an indie rock funk something. Which of the two is better? So we'll get the sum of all the genre columns. It's ones and zeros. So if it has one genre, it's just 1 in the multiple genres column. If it's 5 genres, it's going to be a 5 because we're summing the ones. And it also going to be a way to filter through genres. We can filter out the songs that don't have genre information at all. If it's 0 in the multiple genres, like here, we'll just filter these out for the analysis. Right, so what we have now is a table that has a track name, track play count, track listeners, track ID, which we'll delete probably later on, what artist's track this is, track rank, which is what rank this track has for the artist. Is it number 1 track, number 2 track, or number 50, depending on the track's play count, where 1 is most played. Track duration, tags, publication date, play count, listeners for the artists, ID for the artist, tags for the artist, genre information, and multiple genres, the count of how many genres use the song fits into. That's what we got. In the next video, we're gonna explore the data. That was preparation of the data. And data preparation is usually the most tedious part of data analysis. It takes the most time, takes the most creative effort. If you learn this, you learn data analysis, basically. That's the most difficult part of it. Once again, I got the Google Colab notebook linked in the video information section. You can freely access it, and the code is available for you to copy and edit if you need. Right, I hope you found this as fun as I did. Right, join me in later videos, hit the bell icon to get notified when the next video comes out. Leave a comment, like and subscribe. Thank you for watching, and I hope you didn't yawn too much during this video, because you're awesome. Yes, you are.